If you've ever bought a box of strawberries and watched them go bad in the fridge almost overnight, while a bag of apples seems to last for weeks or even months, you're not imagining things. Some fruits are built to survive long journeys and long storage times, while others are basically living on borrowed time the moment they're picked. And the reason comes down to a mix of chemistry, biology, and how fruit evolved in the first place. Let's start with apples. Apples are natural long haulers. When an apple is picked from the tree, it doesn't stop being alive. It's still breathing, still using oxygen, and still slowly changing on the inside. But it does all of that very, very slowly. Apples have a low respiration rate, which means they burn through their stored sugars at a snail's pace. The slower a fruit respires, the longer it stays firm and edible. Apples also produce a gas called ethylene. Ethylene is a ripening hormone that tells fruit, hey, it's time to soften, sweeten, and eventually rot. But apples release ethylene in a controlled, gradual way. That slow release keeps the ripening process from going into overdrive. In fact, apples are so sensitive to ethylene that storing them with other fruits can actually make those fruits ripen faster. Then there's the apple's skin. That shiny, smooth peel isn't just for looks. It's thick, tough, and coated in natural waxes that act like a built-in moisture barrier. This slows water loss and keeps microbes from getting inside. Less moisture escaping means less shriveling, and fewer openings mean fewer chances for mold and bacteria to move in. Inside, apples are also more acidic than many people realize. That lower pH makes life harder for spoilage organisms. Bacteria and mold don't thrive as easily in acidic environments, which gives apples yet another advantage in the longevity department. Now compare that to berries. Strawberries, raspberries, blueberries, delicious, but fragile. Berries have an extremely high respiration rate. From the moment they're picked, their metabolism is racing. Sugars are being consumed quickly, tissues are breaking down fast, and there's no slow burn mode to save them. Berries also lack a true protective skin. What you see is basically what you get. Their outer layer is thin, delicate, and easily damaged. Tiny bruises and micro cracks form during harvesting and transport, even when they look perfect to your eye. Those microscopic injuries are open doors for mold spores and bacteria. Water is another huge factor. Berries are packed with moisture, which is great for juiciness, but terrible for shelf life. Moist environments are a playground for mold, especially the fuzzy grey kind that seems to appear out of nowhere. Apples lose moisture slowly. Berries lose structure fast. Acidity plays a role here too. While some berries are acidic, their overall chemistry and soft tissues make them far more vulnerable to microbial growth. And once spoilage starts in one berry, it spreads quickly to its neighbours. That's why one bad strawberry can ruin the entire carton. Evolution also explains a lot of this. Apples evolved to fall from trees and sit on the ground for a while before being eaten. They needed to protect their seeds long enough for animals to come along. Tough skin, slow ripening, and long storage life were survival advantages. Berries, on the other hand, evolved for speed. Their job was to be bright, sweet, and irresistible, fast. Animals eat them quickly, spread the seeds quickly, and the plant moves on. Longevity wasn't part of the plan. This is also why modern storage techniques work so well for apples. In commercial storage, apples are kept in cold rooms with carefully controlled oxygen and carbon dioxide levels. This slows respiration even more, essentially putting the apple into a kind of suspended animation. That's how apples harvested in the fall can still be crisp and fresh months later. Berries don't respond nearly as well to those tricks. Cold can slow them down a little, but it can't change their fundamental biology. They're simply not designed to wait. So the next time you're frustrated that your berries went bad after a few days, remember, it's not poor quality or bad luck. It's chemistry, evolution, and biology all working exactly as intended. If you enjoyed this breakdown of why some foods last longer than others, give the video a like and subscribe for more food science explained simply. Thanks for watching, and I'll see you in the next one.